Okay, so this is chapter 9 of L's book on Python, and we're talking about files, and then we'll also talk about exceptions. And the idea here, the perspective here is that without files, we wouldn't have persistence. We write a program and we use data. For example, we have lists and so forth that contain our data, or pandas. But once the program stops running, we lose the data. If we don't, so what we could do is store it in a file. So that brings us to the topic of files, and then the question is, how do we use files in Python? So here's the table of contents. So we're going to files, then text file processing. And this, by the way, the preceding chapter is on strings. So we're assuming that strings has been covered already. So then we talk about text files in particular and writing to a text file. And they suggest that using with is better than just using open, because you may forget to close, but with you don't have to worry about that. It will close it for you. And if you don't close a file or some other resource, then that prevents another process from using that file. So you may not want that to happen. And then we talk about updating text files as opposed to overwriting them, which is what happens. Overwriting them is what happens when you just open them for writing, they just delete. That open function will delete the entire contents of the file, which is probably not typically what you want to happen. So more typically, we would like to update a file. So we'll talk about that as well. And then we'll go on to JSON. And we'll also talk about Pickle, but we'll talk about actually the security problems with Pickle. And then after we cover that, we'll go on to basically entirely different topic, which is exceptions. Okay, so it says Python views a text file as a sequence of characters. So a binary file, on the other hand, like that's a file that might store an image like a JPEG file or a video or something else, is a sequence of bytes. So that might look something like this. If you looked at it in a text editor, it looks like nonsense, like this. But if you look at it through a hex file editor, it would look more sensible like this, because each of these is a byte. You can view it more sensibly like that. But actually, we're not concerned with binary files here. We're concerned with text files. So with regard to a text file, yeah, it makes sense that it should be a sequence of characters, because that's what we see in a text file. We might have a word in the text file or a sentence, something like that. And when we count the first word, the first letter, the second letter, the third letter, and so on, just like for lists and arrays, we talk about counting from 0. So instead of calling it the first letter in the file, we'd call it either the 0th letter, or maybe it's better to say the letter with index 0. So next they mention here the end of file marker. So there used to be, a long time ago, there used to be actually a token, like I think it was EOF, end of file, that would sit at the end of the last token in the file, and that would tell you that it was the end. But now it's usually just like a length measurement that tells you where to stop or where it stops. But anyway, they say every operating system provides a mechanism to denote the end of a file. Some represent it with an end of file marker. I don't think that really happens anymore, while others might maintain a count of the total characters or bytes in the file. And even if they do have an end of file, they usually hide it from you. So for example, if you look at, here's a Notepad+, and this is a file, has a sentence in it, And if you can actually see some characters that aren't typically displayed by going to View up here and Show Symbol, and we'll try Show All Characters. So here you can see that there's a control and a line feed character, but they weren't really visible. They weren't visible. Notepad Plus doesn't show you that, even though it's actually there, because it's just distracting. So it's not really part of what we want to see. So typically you don't see it, but you could see it here. And so that might have been true with end of file tokens, but you don't see an end of file here. So I guess it's not storing an end of file here in Notepad Plus when you type something. Okay, so next we want to talk about something called standard file objects. This has always been confusing to me, but so the idea is best understood. Let's just read it first, and then, but I don't think it's that clear. But let's just read it. So they say, when a Python program begins execution, it creates 3 standard file objects. So that's not very clear. And then it names them, and this is the standard input file object, standard output file object, standard error file. Okay, so who cares, right? They're just names. So not clear at all yet. Then it just goes on from there and doesn't give us any clue really about what it's talking about, because it says, though these are considered file objects. So what does that mean? Because they did say they were file objects, but so what? They do not read from or write to files by default. Okay, that's not very clear. The input function implicitly uses, okay, so now it says the input function, which we've seen before. That's a function, which I really hate the way they write this, because yeah, this is a different font. So if you're able to see it clearly, you can see that this is supposed to be like code, but it's hard to see that this is code. But anyway, the input function explicitly uses this standard input file object to get the user input from the keyboard. Okay, this is where it seems really like a bad explanation, because what are they talking about? To get the user input from the keyboard. What does that have to do with anything? It seems so remote, this explanation. Then they go on. Function, the function, I hate this language. Function print explicitly, I would say the function print, not function print. Not good English, if you ask me. But anyway, function print implicitly outputs to sys standard out. Okay, this is not clear at all. So here's the idea behind it. So what they're saying is that you have a Python interpreter. When you install Python, you get what's called a Python interpreter as part of what you install, and that will read your code, what they call the source code. That's the code that you type. It will read it and figure out what it means, because it's just says things like print or def or whatever it says. So that's not English. And anyway, it's obviously the Python language, but it's the job of the interpreter to understand that source file. So that's what it does. Now the idea though is that if you just have a really simple program that like takes 2 values and adds them together and stores that in a variable, and that's it. Doesn't do anything, doesn't print anything, doesn't accept anything from you. It's super, super simple. Then you don't need the standard input file object, the standard output file object, and so on. But if you want to end up printing that result to somewhere, for example, if you want to print it to the screen, that's that's something that's done outside of the actual source code. That's what sys standard out would do. So it might send, it's an object that if you run the print statement somewhere in your source code, so if you run that print, then actually what it does is it prints to this standard output file object. And then that could be connected to your screen or somewhere else, but this is what it gets sent to when we print something. And then this will handle it and probably send it to your screen, but you could change that. And the same thing with the input. In that first example I just gave, where we just have a Python file, that a .py file, and we're not doing any typing like in an interactive session or anything. So there's no need for it to connect to my keyboard. But on the other hand, there might be, if you use the input function, then it's expecting something from the keyboard. So actually it goes to some intermediary object called the standard input file object from the keyboard, and then that takes it to the Python program. And then there's also something about the standard error. So we've seen when there's an error, something gets printed, and it's again handled by an object, and then that object decides where to show it. And typically it will show it, if we're doing something interactive, it will show it in that session, or we've seen that happen in Colab, so it will show us the error. So first it goes to this standard error file object, and then it goes to whatever interface we happen to be using. So they say, actually, if you want to refer to these objects, which we typically don't want to refer to these objects, but if we did, we'd have to import the sys module to do that. But they say, but this is rare that we want to do that. Okay, so let's go to section 9.3, text file processing. Okay, so we're going to create this file here, accounts.txt, and we're going to write 5 client records to the file. And then at the end, we're going to have a new line for each line. So it's not just going to be a run-on string. So as we briefly mentioned, we're going to use with here. So we'll explain this in a little bit more detail, but we're going to use open, but when we use open, if we didn't use with, we'd have to worry about closing it. Okay, so first in open, we give the name of the file that we want to create or open. So that's actually a slight point of confusion. So when we open a file, we can actually create it. And we have a mode parameter here, and we're going to set it to W, which means to write. And as I think we mentioned earlier, if this file already exists, then we would kill everything that was in there. We would rewrite everything that was in there if we use W. And then we're going to create a sort of an alias here called accounts. So accounts will have a write method, and we'll use that here. And we're just adding in some text, including the new line. And then we can do it again and again. And then he says you can also write to a file with print, and in that case you don't actually have to put in the new line because print automatically inserts a new line. And here we refer to accounts here, and we use its write method, but print is a standalone function, but we have to refer to the file, and we use the alias here, accounts. So here he says that many applications acquire resources. We're acquiring a resource, so to speak. We're acquiring this resource, and other, such as files, that's what we were acquiring, or sometimes a network connection or a database connection, and so on. And it says you should release resources as soon as they're no longer needed. You have to close them. But if you use Python's with statement, then it will handle that for us. So it says here that the Python's with statement acquires a resource, in this case the file object accounts.txt, and assigns it its corresponding object to a variable accounts. So we already knew that. And with also allows the application to use the resource via that variable, via accounts, and automatically calls the resource object's close method to release the resource when program control reaches the end of the with statements suite. So the built-in open function, which we just used, opens this file called accounts.txt, and it associates it with a file object. We're not going to talk about the file object, but it's the file object that is associated with accounts here. So basically it associates it with accounts, we'll say. But you can see that accounts is just a name, so it must be pointing to something, and it's pointing to an instance of a particular class, probably a class related to text. And then we also have the mode up here, and it says the mode argument specifies the file open mode, indicating whether to open a file for reading from the file, which is not what we did, or writing to the file, or both. The mode W opens the file for writing, and it actually creates the file if it doesn't exist. So it's a little bit counterintuitive, but that's the way it works. So if you don't, and also if you don't specify a path to the file, Python creates it in the current folder. And then it warns us that opening a file for writing deletes all the existing data in the file. And by convention, if you name it like this, it means it's going to be a plain text file. So in our example, we called the file object's write method 5 times, here, 5 times, and then to write 5 records, and at the end of the with statements suite, the with statement implicitly calls the file object's close method to close the file. So if you actually ran that code, you would create an accounts.txt file. And I guess this is the first time we've actually created something on our hard drive. And it would be, and if we open it up, hopefully we would see this there. So the next thing we'll do is we'll read the file and display its contents. So of course we could just open up the file and see its contents, but we're going to do that within our code. We're going to do that with our Python code. So we just created the file and we wrote some data to it. Now let's read that data from the file sequentially from beginning to end. So you might say, why do you have to do it that way? That's the way we're going to do it. The following session reads records from the file accounts.txt and displays the contents of each record in columns with the account and name column left aligned and the balance column right aligned. So what does that mean? So here, this is left aligned. You can see it's aligned here, aligned here, and this one is right aligned here. And what do we mean by the records? We just mean these. This is the first record, this is the second record, and so on. So that's what we mean by the records. So here we're printing out the header, and this is the left align and left align, and this is right align. Okay, so the name, as before, we call it accounts. We're using with open, and we're same file, but this time we're using the read mode, but again we're calling it accounts. And now we're just calling the index for this record, but it's just a for loop, and we're going through accounts, and then we're gonna, what this will pull up by iterating through this, it means that we'll pull up the first line and then the second line and then the third line and so on. So it's delineated by the new line character, which means we put in the new line up here somewhere, and as soon as we get to a new line, then the next record would be here. So we're getting each record, and then a record actually has 3 elements in it, and they're delineated by the spaces. The record, we split the record, and the default character for splitting is space. So we create a list of 3 elements, and then we can extract them using this. Okay, and then we continue through in the same iteration here. We left align account, left align name, and right align balance from count, name, and balance. And then we go through the for loop, so we're going to print out this one, and this one, and so on. Okay, so we said we're using read here. So if the contents of a file should not be modified, open the file, we're opening the file for reading only, or for R. Another example of the principle of least privilege, I don't think we covered that, but so we can imagine that just means don't give too many privileges to something if you don't have to. So we don't give writing privilege unless we have to. So this prevents the program from accidentally modifying the file. You can open a file for reading by passing the R file open mode as function opens second argument. If you don't specify the folder in which to store the file, open assumes the file is in the current folder. Okay, so this sentence explains the formatting that we did when we did this line here, and also when we did this line up here. So it means we're reserving 10 spaces, and we're left aligning. And here we're reserving 10 spaces, and we're left aligning. And here we're reserving 10 spaces, and we're right aligning. Well, let's read that. The last statement in the for statements suite displays these variables in columns using field widths. So here we're talking about another method called readLines. So it's an alternative to this for loop here. So the for loop, remember, reads line by line, and by line we mean delineated by the new line character. So here we're reading line by line, but instead of that we can use read lines. So that would be accounts, because accounts was the name of the object, and then dot read lines, and that will read in the entire text file, and it returns each line as a string. It returns a list of those strings. So then they say that for small files this works well, but iterating over the lines in a file object as shown before can be more efficient, because when you call read lines for a large file, it has to complete before you can begin using the list of strings. So on the other hand, if you use it as we did before in a for loop statement, then you can, at each iteration, you can perform some actions. You don't really have to wait until the whole thing is finished before performing such an action. And furthermore, since file objects, like accounts, are already iterable line by line, you can actually get the same list that you would with read lines just by doing list on accounts. So read lines is not something that's used much anymore. Okay, so this section tells us how we could update a text file, and it describes a pretty tedious and actually hard to believe way that you would update a text file. And the reason it's hard to believe is because we never do this manually, or rarely do we do this manually, because usually we're just using a text editor, and it actually does this behind the scenes. So it might be worth going over this to see actually what you would have to do if you wanted to do it in Python. So here's the issue. Formatted data, when written to a text file, cannot be modified without the risk of destroying other data. Now, really what's happening is that the length of a text file is actually fixed. So that's the real problem. But to show what that means, suppose your file looked like this, and then you wanted to change White to Williams. So if you overwrite White with the name Williams, it would end up looking like this. And that's because there's only a certain amount of space that's allocated here. And so we're trying to fit Williams into there. And that's really because the whole file has a fixed length, because it's just a string, actually, a fixed length string. So if you really wanted to do this in Python, what you would have to do is down here. So to make the preceding name change, copy the records before this into a temporary file. Then write the updated and correctly formatted record for the account 300 to this file. So in other words, we'd write 300 Williams, 300 space Williams space, and then 0.00. So you'd type that into the temporary file. Then you'd have to copy the records after that to the temporary file. So whatever was after that was somewhere. So these 400 and 500 records. Okay, so all of that would be in our temporary file. And then we would delete the old file. And finally, we'd rename the temporary file to the original file's name. So if you wanted to do this in Python, you'd actually have to go through this. Now, a regular text editor is not Python, and we don't have to do it ourselves, but actually under the hood, that's actually what it has to do as well when you edit or update a text file. Okay, next they actually show how to do this. So first we open the file accounts.txt for reading, and we use this as the handle or as the object name. And then we open a temporary file with writing mode, and then we use with and accounts and temp file for records in accounts, and then we do the same record split and then assign that to account and name and balance. And then if account is not equal to 300, then write the record to the temporary file. Okay, now don't think that down here. So if account is not equal to 300, so the first time it goes through this, account is equal to, I think it was 100. And so it would write that record, and then the else would not take hold. So we'd go back up to the next iteration of the loop, and then we'd get account was again, it's 200, and so it's again not equal to 300. So we'd complete that, and then it would be 300. This would not apply, and so we would do else. We would now join this record into our file, and this means with a space in between each of these. And then we would write this record plus this new line character to the temporary file, and then we'd continue with the rest of the records. So this doesn't have the part where we have to rename temporary file to the original. We have to delete the original file and rename this temporary file. So we can do that by importing the OS module and do OS remove that, and then OS rename this to accounts.txt. Okay, so now we're going to talk about the next section in the book, but I'm just using this website for a moment. So this is a website called W3 Schools, and you can see the address here. And they have tutorials about many different topics in programming. There are lots of things here. But I wanted to do just the beginning of the introduction to JSON from here first. So let's take a look at this. So they say, what is JSON? It stands for JavaScript Object Notation. It's a lightweight format for storing and transporting data. Basically, it's for data. It's just a way to show data. So we know how to show data. We can just put it in a spreadsheet and show it. But this is an alternative way that can be convenient. Let's go through a little of this. So JSON is often used when data is sent from a server to a web page. So another example of where it might be used is when we're working with agentic AI, we have what are called tools, and we need to let the LLM that we're communicating with know about these tools because we want the LLM to be able to run various tools. So this may sound a little bit abstract at this point, but I'm just, in case you know about it. And so in order to send information about the tool, we could just send actually the definition of the tool. In other words, the tool is a function, and so we could just send the actual code for the function. And I've often wondered why we don't just do that. But anyway, what's typically done is we send JSON, which is a way to describe the inputs and the outputs of the function, not the entire workings of the function, but just what do you have to do, what kind of input do you have to put into it, what kind of output are you expecting to get out of it, and so on. So that's just another example. As I said, I wonder why we don't just give the LLM the actual code for the function, but that's not the way it's done. So they say JSON is self-describing and here, easy to understand. It is very easy to understand. So here's an example of JSON. In this example, we have these outer brackets here, and then we have a key and a value, actually. So this actually, we could think of this as a dictionary with one element in it. But anyway, it's not necessarily a dictionary, but we can, at least here we can think about that. So anyway, we have employees, and then we have some, like the variable names here, first name, first name, first name. And then the first name is John, and the last name is Doe. And first name is here, and last name is here, and first name is here, and last name is here. So that's JSON. So the data obviously is John Doe, Anna Smith, Peter Jones, but the data comes in name value pairs. So we have the variable name and the value, the variable name and the value. So they say data is in name value pairs. Data is separated by commas. So the data here is separated by a comma, and this data is also, this whole record is separated by a comma. Curly braces hold objects, and square brackets hold arrays or lists. So we do have a list here of 3 records. And as an aside here, they say JavaScript object notation, JSON format is syntactically identical to the code for creating JavaScript objects. So we're not writing and using JavaScript. So we're not really concerned with that, but that happens to be true. So like we said, the data comes in name and value pairs. So like here, first name and John. And this JSON objects are written inside curly braces. So we have this, I guess we would consider it a JSON object. Of course, we could consider it a dictionary, but we're calling it a JSON object. And JSON arrays are written inside square brackets, so we could just consider this an array, but here we're calling it a JSON array. And here they're talking about how to convert text to a JavaScript object, but we're not going to do that. We're talking about Python. So here's just a little bit more. This here defines an object with 3 properties. So we have name, age, and car. And each property has a value, John, 30, and null. So why do we use JSON? JSON makes it easy to send and store data. We could consider this data, and we could want to send this to a server or to a program or whatever. And this is just a kind of a sort of organized way of sending it. And if you're using this in JavaScript, you could create an object, and then you could take that object and access its name, or and access its age, and so on. Okay, so going back to our book, here you can see this is at the end of the JSON section, but we have a bit of JSON here. So it goes from here to here, and then we have something called accounts, and it's the same example actually that we've been using, where we had an account 100, we had an account 200, and so on. Here, though, we're storing it in JSON. Here, this is the name of the data, and then we have it as a list of dictionaries. So we have a dictionary, comma, a second dictionary. So each record is a dictionary, and it's a key value pair. We have account 100, name Jones, balance this. Account 200, name Doe, balance this. So that's an example of JSON as well. Okay, let's go through this section 9.5, serialization with JSON. Serialization means taking something like an object and writing it as text so that it can be easily transferred to another program or to a server or something like that. So you have to clearly define what's in the object so that you can reconstruct it when you get it back as you get it as text, and the server might get it as text, and then it might want to reconstruct the object in the object form that, for example, your Python program, maybe you have the Python program also in the server, and your Python program in the server will understand. So you can't just give it the text. You have to reconstruct it into the object form, the way the object is actually expressed. So here they say many libraries will use to interact with cloud-based services. So we're talking about sending an object to a cloud-based service such as Twitter or this thing or anything. Communicate with your applications via JSON objects. And as I said, that's also true with agents and LLMs. So you might have, as I said, what's called a tool, which is just a function definition on your system, and you need to communicate that to the LLM, and you write a kind of description of it using JSON and send that to the LLM. Okay, anyway, JSON, JavaScript object notation, is a text-based, so it's like text, basically, human and computer readable. So it's quite human readable. I think we saw that. Data interchange format used to represent objects. So we can represent dictionaries or lists or more, even like database contents, as collections of name-value pairs. And we're using that name-value pair format or structure. JSON can even represent objects of custom classes that you choose to build in the next chapter. So we haven't talked about that yet, but we'll talk about that. JSON has become the preferred data format for transmitting objects across platforms. This is especially true for invoking cloud-based web services, which are functions and methods that you call over the internet. You'll become proficient at working with JSON data in here, but we'll store JSON tweet objects that we obtain from Twitter in MongoDB, so in some database. So we're going to take some Twitter tweets and we're going to store them as JSON and then send them to the database, or this NoSQL database, for example, so to a different database. So they say JSON objects are similar to Python dictionaries, and we saw that. Each JSON object contains a comma-separated list of property names and values, in curly braces. For example, the following key value pairs might represent a client record. Okay, so this is the same data that we've been talking about. Account, 100, name, Jones, balance, that. And it's key value pairs in what appears to be a dictionary. But it could also be called JSON. JSON also supports arrays, which, like Python lists, are comma-separated values in square brackets. For example, the following is an acceptable JSON array of numbers. Of course, this looks like a list, but here we're calling it a JSON. In other words, this is also an acceptable JSON object. Okay? Values in JSON, even though, here they're not really named entities. So it might be a little bit less clear what this means, but you can still do this and call it JSON. But this is more typical where you're actually telling what each number is. This is balance, this is name, and this is account. Okay, values in JSON objects and arrays can be strings in double quotes like this Jones, numbers like this, so that they don't have quotes, JSON Boolean values like represented as true or false in JSON, null to represent no value like none in Python, arrays, and other JSON objects. Okay, now let's talk about the Python standard library module JSON. So this is a module in Python. So this module enables you to convert objects to JSON text format, and this is known as serializing the data. Consider the following dictionary, which contains one key value pair consisting of the key accounts, which is associated with its associated value being a list of dictionary representing two accounts. So we have this, and then inside there we have two dictionaries as well. So we have an outer dictionary which contains one element which is called accounts, and then the values for accounts is actually a list of two dictionaries. So a little bit complicated structure, but seems like an obvious way to set things up. And we've called it accounts dictionary. So it's not exactly in JSON right now per se, but we can convert it to JSON by opening it in write mode. So we're opening it. We're going to open a new file called accounts.json in write mode. We'll call it accounts. And then we'll take this and we'll pass it through the json.dump method. And so that's accounts dict, which is here, which is already constructed. And we're going to write it to accounts, so to speak, or dump it into accounts, which is this accounts.json. And that's called serializing the dictionary, or serializing accounts.dict into the file, into this file. Into this file, or into this file. Okay, so let's actually run this in VS Code and see what this file that gets created actually looks like. Okay, so this is the same code. You might need to do import JSON, pip install rather JSON, and then we can just run this. Okay, and then we look for it in this directory here, so I'll look for that, and I can see that it's in that directory. Here it is, and I'll open this up with Notepad. So I can see here, whoops, not that, what happened? There. So you can see that it created it. Now it's all in one line, but this is the accounts.json file, and this could be sent to a server, and then it would understand what you've created. And this would be JSON format. Okay, so let's just read this. This snippet 3 opens the file accounts.json and uses the JSON module's dump function to serialize. Just means to write it as a string typically, which is basically what we just saw. Serialize the dictionary accounts_dict into the file. The resulting file contains the following text, and they said they reformatted it a little because you saw that it was all in one line, so they just broke it up. Otherwise, it contains the same information. And note that JSON delimits strings with double quote characters. So strings have double quotes in JSON. So let's assume that we did that, and the reason we did it was because we wanted to send this information through maybe some API to some cloud service, and then the cloud service wants to reconstruct it as the original object, perhaps. The JSON module's load function reads, so we're going to use JSON.load. We're going to take this file, we're going to read it using the read mode of open, and we're going to refer to it as accounts, and we're going to pass that through JSON.load, and now that's going to deserialize JSON. So the JSON module's load function reads the entire JSON content of its file object argument and converts the JSON into a Python object. This is known as deserializing the data. Let's reconstruct the original Python object from this JSON text. So they say we can now interact with the loaded object. For example, we can display the dictionary like this. If you refer to it as if you refer to it as accounts_JSON, then you can just, which we did up here, then we can just print it out and see it as a dictionary. And you can treat that as a dictionary. Yeah, so now it can be treated as a dictionary, whereas when it was originally in JSON, it wouldn't actually be treated as a dictionary. For example, you can say accounts here, and you'll get this whole key value here. So accounts, and you get the whole value. And you can also talk about accounts 0, again, treating it as a dictionary, and you'll get the first record. So we use the dump function to write it as JSON, and then we used a load to deserialize it. So here they say the JSON module's dumps function, dumps is short for dump string, so that's why it's S, returns a Python string representation of an object in JSON format. So they say in that dumps, which is the first thing we did, and you can use this and then print the whole thing, and you can get it to look like this, which is more usually the way people display JSON.